In today's math lesson, we're going to identify functions using the vertical line test. So the vertical line test is really a great little test. And what you do is draw a vertical line straight up and down anywhere on your graph. If your vertical line touches the graphed line, that figure, the shape, the curve, more than once, anywhere, it is not a function. In example 1, we are looking at this graphed curve parabola. We want to know if this relation is a function. To do the vertical line test, you could pick anywhere, and I mean literally anywhere and everywhere, to draw a vertical line through your curve, which in this particular problem is a parabola. If any of these red lines had been able to stretch vertically up and down and bump into the curve more than once, anywhere at all, then the answer would be no, this was not a function. Since each red line, every single one of these that I drew, was able to touch this curve, this parabola, only once, only at one location every time I drew a vertical line, then we are able to say yes, this is a function. And there you go. In example 2, we want to know if this graph of an ellipse is a function. So let's use the vertical line test. So if I draw a vertical line anywhere at all, and we see that this blue vertical line has bumped into our ellipse in not one but 2 locations, that it cannot be a function, because in order to be a function, it must only hit the curve one time. So this is equivalent to saying that 2 locations had the same x value as we move across the x-axis. That is how the vertical line test works. And there you go. In example 3, we want to see if the given graph of this particular relation also happens to be a function. So we stated in the introduction that you have to be able to draw a vertical line anywhere, everywhere, and have it only bump into your curve, your figure, at one location every time you do it. That's the rule of being a function. While you can draw some vertical lines that only touch the curve once, there is a region of the curve that has not 1, not 2, but 3 points that are intersected by the vertical line. And those 3 points are right here. Since the rules of being a function is allowing for everywhere to only be intersected at one location, and this is broken in this small region, therefore we have to conclude that no, this is not a function. And there you go. In example 4, we are going to look at this graph and determine if the relation shown is a function. So this graph shows points and lines. Let's find out what the point rules are. Rule number 1, if you have a solid point above another solid point, then the answer is no, this is not a function. What might that look like? So, for example, if you had a line with a solid point at the end of it, directly below another line, even though the lines are going in opposite directions, even though these 2 points are directly above each other, the answer is no, this would not be a function. Our second possibility is if you had a solid point either above or below an open point, then the answer would be yes, this is a function. So what might that look like? So if you had, for example, a segment with an open point directly above another line that had a closed solid point, this would work. This would be just fine. Or if you had, say, a solid point above the open point, this would also be just fine. Those are both examples of functions. The third point option would be to have an open point above another open point. So what might that look like? That might be something like this. Here's an open point, and directly below it is another open point. So this would be another example of a function. Now that we know the point rules, let's look at our particular example. So right here at the very beginning, we can see a solid point above another solid point. And it happens again and again. And we see right here in orange that if you have a solid above a solid, the answer is no. This is not a function. And there you go. In our fifth and final example, we're going to look at this graph of lines, line segments, and points, and determine if it is a function. So let's go back to the previous example's point rules, and we saw that if you have a solid point above or below an open point, then yes, it is a function. And if you have an open point above another open point, then yes, that is a function. The only time you were not able to have a function is if you have a solid point above another solid point. So let's look. Vertical line test right here. I have a solid point above an open point, so that works. And here again, vertical line test, I have another solid point above another open point. So these examples do exhibit that of a function because we don't have any solid points or solid lines overlapping. And there you go.